Selamlar tekrar. Ben bunu çözeceğim artık. Çünkü bundan sonra ADMS'yi kullanmayacağız gibi duruyor. Kusura bakmayın. Şunu çözeceğim artık. Okay. Let's continue with the screen that I'm sharing. So I was here. This picture is summarizing the possible explanations. You know, can this be because over optimism? We say no. Like the writer of this article says no. Can this be because of Dunning-Kruger effect, like here? This is like the writer says no. Can it be because pure uncertainty? This guy, writer says no. And he says that this is mainly because of a phenomena that he defines with an example. And I'm going to ask you the question in the example. Let's say that it takes it normally takes 5 minutes to go to the nearest bus stop. Okay, if you have nothing else, and let's say that in a really rainy day, you decided to wait 15 minutes. Sorry, let's say that it takes 5 minutes to walk to the bus stop. Okay, and let's say that in a rainy day, you decided to wait 15 minutes before you jump on the road and walk to the bus stop. And let's say another day in the same month, you seen a friend when you are walking down the road, and you spend 10 minutes talking with them. Okay. We should again ask ourselves, what is the approximate time does it take to get to the bus stop? Will you say, like, will you give the real mean value, or will you say 5 minutes? What do you say? We generally like to give an answer that that maximizes our chance to be right. Okay, this is our psychological thing, and because of that, we say it will take 5 minutes. But like I said, this is not the actual mean value of like, this is not the average value, time value. And we estimate time like we have a perfect bell curve, and if we if we consider that a job should take 5 minutes, then it will be probably 5 minutes. Maybe it will be 6, maybe it will be 4 minutes, but it's really hard to do it in 1 minute, and it's really not possible to do it in 1 hour. Okay, this is how we estimate time. The problem, like, the reality is not this. The reality is our graphic should be skewed. Even if you are really good at estimating the time a task will take, that doesn't mean you will be good at estimating the time the project will take. Counterintuitively, you will be more wrong. um, because generally our estimates will be um, let me read this first. Now we all when we talk about this um, can recognize the graph. I mean, our graph should be right skewed because theoretically it's possible. It's not possible to have a minus value when you're planning your time. I mean, you won't finish your homework in -1 day. It will take at least 1 day, okay? But theoretically, it can take infinite amount of time, and because of that, your graphic is right. Like your graphic should be right skewed, and because of that, the median uh, has a higher probability of being true than the mean um, for that single task. If you were to guess the mode value which has the highest probability, you would be even more wrong on a larger scale. Uh, by larger scale, this means if the thing you are trying to estimate is a huge thing, like a complete project. Any questions so far? The reason I'm discussing this is actually creating an empathy between product managers and code developers. Um, so again, the mode is the um, most repetitive time value for a given task. In our example, it's 5 minutes, since 5 minutes repeats more often. What we want is mean, ortalama, and our like our mode and median will be far away from the mean. This is the problem. And this guy basically has a nice mathematical formula. So for each number of tasks, he calculates the difference between mean time and median time. By this, he means this distance between median and mean, positive distance, of course, and he he collects, he sums them all to find the delay. So this is the total delay for a given product. Our natural guess is based on the median, which maximizes our probability of guessing right. Or we can also say, like we can also give mode to maximize our probability of guessing right. However, real number is when this event occurs more times, that you can calculate the mean of the needed time. Okay. And what are our solutions? It's easier to tell if task X would take more, less, or same time compared to task Y than it is to tell exactly how long they would take. This is because comparing the medians works just as well as comparing the means if the skewness of the curves is roughly the same, which is true for similar tasks. So it's like the important thing to get from here is our time estimates should be relevant to each other. So we will basically, I will talk about a specific pointage system for planning, and you are not trying to estimate time, you are trying to estimate the hardship of this feature, and then you see like you are basically assigning points to each feature. If it's a harder feature, then a higher number of points will be assigned to this feature. And after that, for let's say 2 weeks, you see that's how much points you can finish in 2 weeks. And then you can easily plan ahead rather than having no clue at the speeds of your team. Okay. Another point this guy mentions is I don't recall or record every single similar task to do the math and get the mean. So I usually estimate the inevitable error as a percentage of the task and task time that goes up or down depending on how comfortable I'm with the development environment. Do I have, okay, this suggestion means that you should have a what was it called? You should have a tempen, basically tempen of time, and this this uncertainty value will go up as you are not familiar with the tools you are using, and it will go down if you know what you are doing. So this guy basically tells a rough estimate, and then also talks about how much this estimates can go wrong in either way, you know, as it's in the you know, food boxes. Sometimes it says this is like this box of food has 1 kilogram in it, but it can have plus or minus 10 grams, you know. It's he says something like that. Another solution this guy offers is splitting sprints into equally sized tasks. Just to, okay, let me say what a sprint is actually. So a sprint is koşu in Turkish, and in this case, in product management case, a sprint means how can I say, a period of time for development that you plan ahead, and at the end of the sprint you give a critique on how things went, and you plan the next sprint. So this guy splits his sprints into equally sized tasks just to create some uniformity in the time estimation process. This allows me to benefit from point one. So point one is here. And it should be easy to tell if two tasks are roughly equal in time. This also makes tasks even more similar so that the hypothesis applies even more perfectly and things become more predictable. So this guy basically compares the tasks that he's given, and he takes the same amount of task for each sprint, and he believes that like he will spend roughly the same amount of time. This is a, I would say, fixed product flexible time approach. We can also split sprints into equally sized time windows. This is also doable. So with these principles applied, you can do a test run if you have the resources. For example, if in X1 days with Y1 developers and Z1 of the uniform tasks were completed, then we can easily solve equations for other variables. Like let's say that if we double or triple the days we have, what can we do? We can plan ahead. Or we can also plan ahead if we have more days to work, but mm, uh, like let's say that we have more resources. Let's say that new developers are added to our team, and this time we have more time to develop. Then we can also calculate what can we do with that. So, okay, these are the things that I would like to cover for this part of the lecture. If you don't have any questions, we can give a break. And I will, of course, like give examples of planning. Okay. If you don't, then see you after, let's say, 20 minutes, okay?
See you.